In this lesson, we're going to discuss the addition and subtraction properties of equality. And this is important. These properties are important when solving equations. And so let's quickly review a couple of things. So we're going to review the definition of expression and equation. Okay, so an expression, and it's important you know the difference between the two, because certain operations you do with an equation you can't necessarily do with just an expression, so you have to be careful. So an expression is a combination of operations on variables and numbers. An equation has an equal sign. It must have an equal sign. That's what we call it, an equation. And an equation is a statement that indicates that two expressions are equal. So basically, you're going to see something that's look like this. You have an expression on the left equals the equal sign, and then an expression on the right. So let's look at some examples. So here's some examples of equations and expressions. All right, so we're going to do equations first, and then we'll do expressions. So an example of an equation would look like this. We have 2x minus 1 equals 6. And in this course, you're going to learn how to solve this kind of equation. Notice you have an expression on the left-hand side. You have your equal sign, and you have an expression on your right side. It's just a number, but it's still an expression, because remember the definition of an expression, a combination of operations on variables and numbers. We have a number. And here we have an expression that contains a variable. You have 7 plus 3 equals 3 plus 7. That's also an equation. You don't see any variables, but that's fine. It's still an equation because of that equal sign. So you have an expression which just contains numbers, right, on both sides. So that's the definition of an expression, a combination of operations on numbers. We have 3x plus 7 equals 2x minus 1. That's an equation. You have variables on both sides. You have an expression here and an expression on the right-hand side. And you're going to learn how to solve that kind of equation in this week or within the next few lessons. And then we have this equation, 2 times x minus 1 equals 3x plus 6. Okay, so that's also an equation. It has an equal sign. Remember, all these have equal signs. That's why they're called equations. You're also going to learn how to deal with an equation with an expression that has parentheses with a number in front. All right, so those are examples of equations. For expressions, it looks like this, 2x minus 1, right? So that's an example of an expression. You don't see any equal sign. All right, so by itself, that's just an expression. So don't call this an equation. It's just an expression. And then you have something like 3 times 2y minus 1 plus 6. That's another example of an expression. Notice that in this particular case, at some point, you would have to get rid of the parentheses, and we're going to talk about how to do that as well. You have x to the third power. That's an expression. There's no equal sign. You just see some variable raised to a power. And then you have negative x squared plus 6x minus 1. So in this course, you're going to learn how to deal with, and this will be called a polynomial, and this is a polynomial as well. So you're going to learn how to deal with this. In fact, all of these you're going to learn are polynomials. But so these are expressions. These are equations. All right. Now, so then another thing you have to learn about is this. What do we mean? What do we mean when we say by finding the solution of an equation? By the solution of an equation. What does that mean? A solution to an equation. All right. So for example, let's suppose I ask this question: Is 6 a solution to the following equation? All right, so is 6 a solution to the following equation. All right, so here's the equation, part A. 3x minus 4 equals 18. All right, so I want to know, is 6 a solution to this? So a solution is the value of the variable that will make this equation a true statement. So the value of the variable that will make this equation a true statement. So the left-hand side has to equal the right-hand side. And so one approach you can do to determine if 6 is a solution to this equation is to substitute in place of 6, substitute the value, in place of x rather, substitute the value 6 and use the order of operations. So this is what you're going to do. You're going to say 3 times 6 minus 4, and you want to see if that's going to equal the right-hand side. So is this left-hand side going to equal the right-hand side? So remember the order of operations. Please excuse my dear Aunt Sally. Remember that? So remember the order of operations. So order of operations. So order of operations. You remember. So the acronym you learned was please excuse my dear Aunt Sally. Some math professionals don't like using acronyms, but sometimes it does help students. So the P right here stands for parentheses, although it could mean parentheses, although it could mean any grouping symbol. You could have brackets as well, and so forth, grouping symbols. So you're going to do, if you see any parentheses or grouping symbols, you're going to do that first. Then the next level is exponents. If you see any exponents, you're going to do that next. And then M and D I put together, so that means that you're going to do multiplication and division from left to right, whatever appears first. Multiplication, division, left to right. Whatever appears first as you go from left to right. Whatever appears as you go from left to right. So if division appears first, you do that first. If multiplication appears first, you do that first. And the same thing for addition and subtraction. So you do addition and subtraction. Addition, subtraction from left to right as well. All right, so if subtraction appears first, you do it. If addition appears first, you do it as you go from left to right. Okay, take care of all these, multiplication, division, from left to right. Whatever appears as you go from left to right. Okay, same thing for addition, subtraction, left to right. Okay, so over here, notice that on the left side, I have two operations. I have multiplication and subtraction. Well, remember, multiplication is a higher level than subtraction, so I must do multiplication first. So 6 times 3 is 18. All right, and I normally do one step at a time. And the question is 18 minus 4 equal to 18? Well, so 18 minus 4, then you're going to subtract. 18 minus 4 is 14, and 14 does not equal 18. So 6 is not a solution. 6 is not a solution to this equation. 3x minus 4 equal 18, because the left side does not equal the right side. All right. So now let's look at the next one. Suppose I had this equation instead. So same directions. Is 6 a solution? So let's suppose I had this one. 2x plus 1 equal x plus 7. 2x plus 1 equals x plus 7. So in place of x, you're going to substitute 6 just like we did here. So we have 2 times 6 plus 1, and I want to see if that's going to equal 6 plus 7. All right, so again, order of operations, I have to do multiplication before addition, so I have to do this first. 2 times 6 is 12, and then 12 plus 1, and then 12 plus 1 is 13, right? Over here, I have 6 plus 7, which is 13, and the question is, are those equal? And the answer is yes. That's a true statement. So therefore, what that means is that 6 is a solution. 6 is a solution to the equation 2x plus 1 equals x plus 7. Okay? All right, so that's what we mean by the idea of a solution. All right, so let me kind of summarize that a little. All right, so let's go ahead and summarize what we just learned. So we learned this: the value of the variable that makes an equation a true statement is called a solution. And sometimes you'll hear the word root. So don't confuse what we mean by root. So root and solution mean the same thing. Okay. So the value of the variable that makes an equation a true statement is called a solution or root of the equation of an equation. All right. So the process of finding the solutions of an equation is called solving the equation of for the variable. So you'll see the directions that says solve each of the following equations. So that's the process of finding the solutions. All right, now in this lesson, we're going to focus on equations that are linear. So linear equations. Now later on, you're going to look at quadratic equations later on in the course, but at the beginning, we're going to be focusing on linear equations. Okay, so let's talk about the definition of a linear equation. So, a linear equation in one variable, and notice I use the word one variable because there are linear equations that have two variables like x and y. But for us, we're only going to be dealing with linear equations that just contain one variable. And most of the time it'll be the variable x, but you could have equations with other variables instead of x. But you'll notice that in all the equations we're going to look at, you're going to see just one variable, and it'll be either x. Sometimes you'll see different letters as well. Okay, now this is important though. So it has to be written in this form, or it can be written in the form ax plus b equals c. So notice my variable is x. All right, this number that you're multiplying x by, we're going to call that the coefficient. And then these two numbers here, we're going to call constants because there's no variable attached to it. So it can be written in the form ax plus b equals c, where a, b, and c are real numbers. So they can be decimals, fractions, integers, whole numbers, whatever real number is any real number, I should say. All right, but it's important to see that a cannot be zero though. So it can be any real number, but a cannot be zero. And the reason a cannot be zero is for this reason. Okay, so listen carefully. So I'm going to go ahead and write this over again. So for example, oops, that's C right here. For example, if a were zero, you'd have this, right? But 0 times x is 0. So you have 0 plus b equals c, and then 0 plus b is b, and so you have b equals c. So notice that this last statement no longer has a variable in it. So it's not a linear equation. All right, so a linear equation can be written in the form, you see x to the first power, so you must see an x there. You must see the variable x in your equation. So when I got to this last step, that variable term is no longer there. Okay, so that's why we cannot let the coefficient of x be 0. Okay, now let's look at this idea. Okay, so these are examples of linear equations. I notice I'm using the word linear. 3x plus 5 equal 2. Okay, so notice right away, I'm going to put this as number 1. Notice that right away it's of that form ax plus b equals c. Now sometimes it doesn't have to be in that form, and we'll talk about that, but this one is. A is 3 in this case, b is 5, and c is 2. All right. Here's another example. 2 times 3x plus 7 equals x plus 2. All right, that's an example of a linear equation. Notice you have variables on both sides, but it's the same variable. Okay, so the variable x. So that's what we mean by linear equation in one variable. This is a linear equation in one variable because you just see the variable x. But what I want to make a note of is that these linear equations, they also have a particular property that you need to be aware of. So So what makes this a linear equation is that exponent right here. See, there's no exponent there, but remember, if there's no exponent there, it is understood to, oops, I meant that to be 0, excuse me. C, excuse me, C. What exponent is there, that's understood to be a 1, so x to the first power, okay? All right, so that's that's one of the properties of a linear equation is that that exponent must, that highest exponent you see must be a 1. All right, so these are examples of linear equations. Let me give you one more that you have to deal with at some point. X plus 6 divided by 2 equal, let's say, 3x minus 1. All right, so that's an example of linear equation. Now, notice it doesn't look anything like this right here, like that form or number 1, but it's still a linear equation, because if you look at this variable right here, that's to the first power, and then right here, that's to the first power. So these are examples of equations that are not linear, examples of equations that are not linear, Okay, so number 1, x squared plus 2x equal 5. That equation is not linear. You may say, well, I see an x to the first power. Yes, you do, but you must look at the highest exponent of the variable. So that's an equation in one variable, but the highest exponent is 2. In order to be a linear equation, your largest exponent must be a 1. So this, in fact, right here is a quadratic equation. And you're going to learn how to solve a quadratic equation later on in the course. So this is a quadratic equation because of this 2 right here. Okay, so that 2, the largest exponent 2, exponent of 2, makes it quadratic. And not linear. Okay? So in particular, I just want to say this. I'm going to put a little note here, and I want to be able to tell you that a linear equation in one variable is also called a first degree equation. Because the variable x has an implied exponent of 1. Okay? All right. So these right here are linear equations because if you notice, all the exponents are 1s. Here, this is not linear. This would be quadratic. Because not all the variables have exponent 1. This one is 2. So a quadratic equation, the largest exponent will be 2. Okay? All right. So now let's look at this idea next. Okay, so what do we mean by solving an equation? And in our case, we're talking about linear equation. Okay, so to solve a linear equation in x, in whatever the variable is, we write a series of simpler equations, all equivalent. So all of these simpler equations are equivalent to the original, so that the final statement, the final equation, has the form x equal a number, and sometimes it could be written as the number equal x. Okay? So here's an example of what I'm talking about. So I have this equation right here. So that's my original equation. Here is an equivalent. We use the word equivalent. So here's equivalent to this. Now you're going to learn how to do this, how to go from this step, or to go from the original to this step. And then we have this. So all of these equations right here are equivalent. Okay? All of them are equivalent. So I went from the original and I wrote simpler equations until my final statement is x equal a number. Okay, so you want to end up with x as your last statement. All right, now, what do we mean by equivalent equations? So equivalent equations are equations that have the same solutions. They have the same solutions. So this means that the number above, x equals 4, is a solution to the original statement, to the original equation. All right, so to solve this equation, you're going to write simpler equations, all equivalent, until you get to the statement x equal a number, and that's the solution to all of the previous statements, all the previous equations. So see these. So all these equations are equivalent. So x equals 4. I want to show you. I'm going to write these over. So 2x minus 3 equals 5. 2x equals 8. And then the last statement was x equals 4. So these equations are equivalent. They have the same solution. Because if I substitute in this one here, if I substitute 4, because as we said the last statement was, if we substitute 4, 2 times 4, and you want to see that's equal to 8, and that's true. 2 times 4 is 8, and 8 does equal 8. Okay? Over here, 2 times 4, 2 times 4 minus 3, and you want to see that's going to equal 5. Well, 2 times 4, I'm going to write it here. 2 times 4 is 8, and 8 minus 3 is 5, which is what this was. Okay? So that's what we mean by equivalent. All right? Now, the following two properties of equality helps us to write simpler equivalent equations. So the following two properties, and there are other properties, but we're going to look at these two first. And so the two properties are these: the addition property of equality and subtraction property of equality. Now, some textbooks will only deal with addition because subtraction is a consequence of addition. So you'll see what I mean in a little while. But sometimes, depending on the textbook, they'll just use the addition property of equality and imply subtraction with it. Okay, so let's talk about the addition property of equality. So what do you mean by the addition property of equality? All right, so first of all, let's make the statement. We're going to assume that A, B, and C, I'm going to use those letters in a little while, A, B, and C are real numbers. Okay? We're talking about real numbers here, are real numbers. So the addition property of equality says this: if you have a statement that says A, I'm going to put some space, well, let me just do this. If you have a statement that says A equals B, okay, then so A equals B, then I can take another number and add it to both sides, and it'll still be equivalent. So A plus C must equal B plus C. So if I add C to the left side, I've got to add C to the right side to keep that equation balanced. So just think about keeping things balanced like you would on a balanced scale. All right, so that's the addition property of equality. Now let's talk about the subtraction property of equality. Okay, so the subtraction property of equality says this: if A equals B, then, so if I subtract C from the left side, I have to subtract C from the right side. So if I say A minus C, then I have to say B minus C. Okay? All right, so that's the addition property of equality and the subtraction property of equality. Now, how do we use these in terms of equations? Now, before I do that, let me just kind of make sure you understand this makes sense. So, for example, we know that this statement is true. So 3 equals 3, right? So 3 equals 3. So if I add 2 to 3 on the left side, then to make these two sides equal, then what must I do to this side? I must add 2 as well. So what you do to the left, you do to the right. Okay? So that's the idea of trying to make things balance. Okay. All right, now let's go ahead and look at this. So if I have, let's say, 3 equals 2 plus 1, y'all know that's a true statement. So if I were to, let's say, add 5 to the left side, then here's the right side, then I have to add 5 to that as well, right? To make it a true statement. So I took both sides and I added 5. And it's still true because 3 plus 5 is 8, 2 plus 1 is 3, and 3 plus 5 is 8. Okay, so here's what you got to remember. If you add you add or subtract, if you add or subtract a number, a real number, from one side of the equation, you have to do it to the other side. You have to do the same thing, the same operation, do the same operation to the other side. Okay? All right, now, before I go on, remember we made the statement a while ago that subtraction is a consequence of addition. So most textbooks, I shouldn't say most, but some textbook will only use the word the addition property of equality and not mention this. And here's why. So this statement here that we made earlier, where we have A equal B, and then we said if I subtract C from A, I must subtract C from B, right? So notice those two statements are equivalent. Those are equivalent statements because those are true statements. These two statements are equivalent because what I did to the left side, I also did to the right side. Okay, and the reason why subtraction comes from addition is this: we may subtract the number from both sides, since subtraction is defined in terms of addition. Okay, so for example, we all know that the statement 7 minus 9, so if I have the statement 7 minus 9, 7 subtract 9, see I use the word subtract, 7 subtract 9, we all know that we can rewrite subtraction as an addition problem like this, 7 plus a negative 9, right? So these two statements are equivalent. So we can write subtraction in terms of addition. And so what I did here was use the fact that when I have subtraction, I can change it to addition by adding the opposite of 9. So the opposite of 9 is negative 9. So I use the word add the opposite. So remember in previous courses when you change subtraction to addition problem, you added the opposite. So that's why you see a negative 9 there. Okay? And those are equivalent expressions. Those are equivalent expressions. Okay? All right, so now what we're going to do is we're going to solve some linear equations using these properties, the addition property of equality or the subtraction property of equality. Okay, so let's look at some examples. So the directions will say something like this. It will say solve each equation. I'm just go ahead and get another sheet of paper. All right, so solve each equation. Now the equations again we're going to look at are going to be linear. So here's the first one. X minus 2 equal 6. X minus 2 equal 6. Now here's how you're going to deal with this. So you're trying to solve this equation and you need to show some work. I know that you can easily determine what the solution is because in your mind you're saying, well, what number subtract 2 is 6? Well, what do you think that solution is? That solution is 8, right? Because 8 minus 2 is 6. So when we do the work, you'll get x to be 8. All right, but if the direction says show work, you got to show work. I know mentally you can look at this and determine what the solution is, but you got to show the work because you got to practice those properties. The whole point of this lesson is to practice your properties, know how to write, know how to use those properties mathematically. Okay? All right, so there are two ways I'm going to do this. I'm not going to do all problems like this. I'm going to show you two ways. So some students will do it horizontally and some students will do it vertically. And I'll discuss what I mean by that. Okay, so I'm going to go ahead and rewrite this problem over. So x minus 2, I'm going to leave some space, equal 6. So notice I left some space here. Okay, so the idea is to get the variable x by itself. All right, now right now I'm subtracting 2, correct? And the opposite of subtracting 2 is, remember we used the word opposite earlier? So the opposite of subtracting 2 is to add 2. So I want you to notice something. If I add 2 here, and again, I have to add it to both sides, right? So what you do to one side, you do to the other side. That's the addition property of equality. So I'm using the addition property of equality. Addition property of equality. So I'm adding 2 to the left side. I'm going to add 2 to the right side. And the purpose of thinking like I just did, I'm subtracting 2 from x, the opposite. Think of the word opposite. The opposite is to add. Okay? So the whole idea is that when you combine like terms, a negative 2 and a positive 2 is 0. This right here is 0. And so x plus 0 is x. You get x to be, and then this right here is 8. So that's your solution. So that's your solution or your root. Okay? All right, now here's another approach that another way you can do this, and that's the way I normally do it. You have x minus 2 equals 6. All right, and so remember, addition property of equality, what you do to one side, you do to the other. Okay, you got to show that mathematically. You have to show plus 2 plus 2. You must do that. Your statements must be mathematically correct. So here, instead of doing it horizontally, like I added 2 horizontally to both sides, I'm going to do this. I'm going to add 2 to this side. I'm going to add 2 to this side, just like that. So this right here means the same thing as this. Okay? So those mean the same thing. And then combining like terms like I did here, remember negative 2 plus 2 is 0. Then here, these two add up to be 0, right? Negative 2 and a positive 2 is 0. And so you have x plus 0 is x equal, and then 6 plus 2 is 8. And there's your solution. So it does not matter which approach you take, horizontally or vertically. It's up to you. All right, so let's look at number 2. Oh, and by the way, here's what I see some students do, and I need to tell you this because some of you are going to do this. So you have x minus 2 equals 6. Some students will just do this. I don't know what you mean by that. So see, there's nothing there, nothing in front. All right, so don't do 2 and 2. You got to put an operation with it. Are you subtracting 2 or are you adding 2 to both sides? Okay? And so don't do that. That's not what you need to be doing. You need to be putting an operation there. Adding. Okay? All right. So always think the opposite though. I'm subtracting 2. Always do the opposite to make sure you get that 0 there. You want to get that negative 2 to the other side. So you got to think about how can I get 0 here. All right? Okay, number 2. So number 2, we have x plus 5 equals 7. Okay, so same idea. I'm adding 5. You got to think the opposite. What's the opposite of adding 5? Subtracting 5. So now I'm going to use the subtraction property of equality. So subtraction property of equality. Subtraction property of equality. So let me go ahead and rewrite this over. So we're going to subtract 5 from both sides. Notice I'm doing it both sides. You must show that. Subtract 5, subtract 5. And now we're going to combine like terms. 5 and a negative 5, that's 0. So x plus 0 is x. Equal 7 subtract 5 is 2. So there's my solution. All right, and you're done. That's your solution. That kind of makes sense because you can always check, right? You can always check. If I'm saying 2 is the solution, what's 2 plus 5? 2 plus 5 is 7. Okay, so that's number 2. All right, let's look at number 3. Number 3, we have x plus 1.8 equals 0.5. X plus 1.8 equals 0.5. All right, so Again, I'm trying to get x by itself. Right now I'm adding 1.8. Now we're dealing with decimals, so you may need to use your calculator if you need to. So x plus 1.8, if the opposite of adding 1.8 is to subtract 1.8, so I'm subtract 1.8 from both sides, okay? And then 1.8 minus 1.8 is 0, and so x plus 0 is x, equal, and then using your calculator, if you need to, 0.5, so 0.5 minus 1.8 is negative 1.3. So x equals negative 1.3. Okay? All right, now, so now let's go ahead and check. So let's go ahead and check this. So let's check. So when we check, we go back to the original problem, x plus 1.8 equal 0.5, right? So in place of x, I'm going to substitute negative 1.8. So negative 1.8, I'm sorry, negative 1.3. Negative 1.3 plus 1.8. So using your calculator, negative 1.3, make sure you know where the negative button is on your calculator. Negative 1.3 plus 1.8 gives us 0.5, which is what the other side was. Okay? All right. Let's go to number 4. So number 4, we have this t, that's the variable t, minus 7.6 equals a negative 9.2. Okay? So we're dealing with a linear equation. It has a variable t, but it's raised to the first power. I want to get it by itself, so I want to solve this. So we're going to add, see right now I'm subtracting 7.6. So I'm going to add 7.6 to both sides, just like this. Okay? A negative, and then combine like terms. Negative 7.6 plus 7.6 is 0. So I get t equals, and then using your calculator, make sure you know how to use your calculator, negative 9.2 plus 7.6 equals negative 1.6. So that's negative 1.6. All right. Now let me just kind of remind you. So in this course you can use your calculator, but let's suppose you didn't have access to your calculator. Do y'all remember how to add signed numbers? So this right here is negative 9.2 plus 7.6. Negative 9.2 plus 7.6. So remember how to do this without a calculator? So what you learned was this, that when you add two numbers whose signs are different, so this is negative and this is positive, positive 7.6, I'm adding two numbers whose signs are different. You subtract their absolute values. Remember that? Subtract their absolute values. And then take the sign of the number with the largest absolute value. All right, so for example, so I'm adding two numbers whose signs are different, so I'm going to subtract. All right, so I'm going to subtract. So I'm going to subtract. So the absolute value of negative 9.2, the absolute value of negative 9.2 is a positive 9.2. The absolute value of negative 9.2 is a positive 9.2. The absolute value of 7.6 is 7.6. So you're going to subtract their absolute values. So these are the absolute values of those two numbers. I'm going to subtract them. Always put the large absolute value on top. So 9.2 minus 7.6. Remember, when subtracting decimals, you align your place value. So I cannot subtract 6 from 2, so I have to borrow. Remember that? And then borrow 1, and then this 2 becomes a 12. 6 from 12 is 6. 7 from 8 is 1. So I got 1.6. Okay? But then you got to take the sign of the one with the large absolute value. So this is a large absolute value, and that sign was negative. So the answer here then would be negative 1.6, which is what you saw here. So I just wanted to remind you how to subtract, how to add signed numbers if you didn't have access to your calculator. And if you want to check, you can check this. So go back to the original, always go back to the original problem, okay? And in place of t, you're going to substitute negative 1.6. I have negative 1.6 minus 7.6, and I want to see if that's going to equal to a negative 9.2. So on your calculator, use your calculator, you know how to use your calculator. Negative 1.6 minus 7.6 equals negative 9.2. Okay? And so this is correct. All right, so that was number 4. Okay, let's look at number 5. All right, number 5, we have this. We have 7 equals negative 4 plus x. Okay, it just turns out that the variable is appearing on the right side, and it looks different than the other 4, and that's fine. We can handle that. So there are different ways you can rewrite it, though, to make it more fitting to you, and we're going to look at that. First of all, notice that I'm trying to get the variable x by itself. Now, if I add 4 here, and then think about combining like terms, a negative 4 and a positive 4, that's 0. So therefore 0 plus x is x. But what I do to the right side, I have to do to the left side. All right, so make sure you show that. Plus 4, okay? And then 7 plus 4 is 11, so I got 11 to be equal to x. And so that will be your solution. So you can say 11 equal x, or you can say x equal 11. Does not matter, right? Does not matter. All right, now I want to just show you this as well. So I'm going to rewrite this problem over. 7 equals negative 4 plus x. Y'all remember that the order in which you add does not matter. So 7 plus x is the same thing as saying 7 plus x, I'm sorry, a negative 4 plus x is the same thing as saying x plus a negative 4, right? Those two mean the same thing. Negative 4 plus x, same thing as saying x plus a negative 4. And don't forget, on this side you have 7. But we also know that x plus a negative 4 means the same thing as x minus 4. So all these statements, all these rational expressions that are on the right are equivalent. Negative 4 plus x means the same thing as x plus a negative 4. So addition is commutative. The order in which you write addition does not matter. Add negative 4 plus x, same thing as x plus negative 4. And x plus negative 4 means the same thing as x minus 4. And now this looks like previous problems like number 4. So we can add 4 to both sides. And so 7 plus 4 is 11. And remember, we add 4 because right now I'm subtracting 4. The opposite of subtracting 4 is to add 4. And this is 0, and you get x. Okay? So it does not matter. It does not matter which approach you use. Okay, let's look at number 6. So number 6, we have this for number 6. We have 7 equals 4 plus x. So that one's a little bit easier than number 5. So this time we have 7 equals 4 plus x. So if you leave it like this, you're trying to get x by itself. So what would you do to both sides? Would you add 4 to both sides, or would you subtract 4? So the question is adding 4 going to help you? Because mathematically that's correct. So let me go ahead and show you. So 7 equals 4 plus x. So if you say add 4 to both sides, think about it though. When you combine like terms, what's 4 plus 4? That's 8, right? So you get 8 plus x equal 11. So that did not help, because remember, you're trying to get x by itself. So always think like that. Is what I'm adding or subtracting from both sides going to help me to get the variable by itself? Because you'd be surprised how many times students get caught up in not thinking about what they're doing. So that did not help. So this did not help. This did not help. Now, I'm going to make the statement. Mathematically, this is correct because I added the same number to both sides. So that's a correct mathematical statement. These two are equivalent, but I'm not solving for x. I'm not getting x by itself. I'm not making those equations simpler. All right, so always think, how can I make the equations simpler? How can I write simpler equivalent equations so that way I can get x by itself? So mathematically, this is correct. but that did not help me. So instead of adding 4, what should I do? Subtract 4. And now that's going to make me get x by itself. 7 subtract 4 is what's that, 3? Equal, this is 0, x. So there's your solution. Kind of makes sense because if I'm saying 3 is a solution, what's 4 plus 3? 4 plus 3 is 7. Okay? Now I just want to say this. Remember we said that this was mathematically correct, right? So this statement, and this statement are equivalent. So if 3 is a solution to this, then 3 better be a solution to this. And it is. What's 8 plus 3? 8 plus 3 is 11. All right? So notice that I did not say this is wrong. All I said was this did not help. All right? So always think about how can I, what operation must I do to get to write simpler equations so that way I can get the variable x by itself. All right? Okay, now let's look at a couple of equations with fractions in it. So this is number 7. So we have y minus 5/8 equals 7/4. Y minus 5/8 equals 7/4. All right, now do not change that to a decimal because those decimals may not always terminate. So leave them as fractions. So we can do the same thing we did before. We're gonna, right now I'm subtracting 5/8, so the opposite is to add 5/8 to both sides, just like this. All right, and then combining like terms, a negative 5/8 plus 5/8 is 0. So I have y equal, and then I have to figure out what 7/4 plus 5/8 is. So let's talk about that. Let's remind ourselves how to add those fractions with unlike denominators. All right, so since those fractions have unlike denominators, we got to find the least common denominator. So the least common denominator of 4 and 8, so the LCD will be 8, right? That's the smallest number that 4 and 8 will go into. And always use the least. Always use the least. So 4 and 8. So the least common denominator is 8. So now what we got to do is write equivalent fractions. So I'm using the word equivalent fractions. Equivalent fractions. So my LCD is 8. This is already an 8, so I got to rewrite this using 8. So I'm going to go ahead and rewrite it over. 7/4 plus 5/8. So I'm going to multiply this by 2 and this by 2. And the reason is because I need this to be an 8, right? So to get that to be an 8, I got to multiply this by 2 to get 8. But what I do to the denominator, I do to the numerator. So I need that to be 7 times 2. So I get this to be 14/8 plus 5/8. All right? So what you may want to do is sometimes what students will do is they'll go to the side like 7/4. So you want 7/4 to have an equivalent fraction with 8 as a denominator. So if I want this to be 8, then I got to multiply this by 2, and so you get 14/8. Now I didn't do anything with this one because the denominators are already the same. So those are already equivalent. And so therefore 14/8 plus 5/8, once you write equivalent fractions with the same denominator, you just add their numerators. 14 plus 5 is 19, so you get 19/8. And then since this is an improper fraction, I'm using the word improper. There's a lot of stuff here, right? So I'm using the word improper. Since improper, let me go ahead and rewrite this over. Improper. Since 14/8 is an improper fraction, let's go ahead and write that. Now remember, an improper fraction is where the numerator is greater than or equal to the denominator. So let's go ahead and write this as a mixed number. So 14/8, I'm sorry, not 14/8, 19/8. 19/8 is going to equal what mixed number? So we're going to divide 8 into 19. 8 to 19. So 8 to the 19 will go 2 times. 2 times 8 is 16 with the remainder of 3. So this becomes 2 and 3/8. 2 and 3/8. And you can always check yourself by multiplying 8 and 2 together and adding the numerator. So 8 times 2 is 16. 16 plus 3 is 19. All right. So y equals 19/8, or you can say 2 and 3/8. So it's okay to leave it as a improper fraction, but make sure it's reduced. That you cannot reduce this. The only common factor that 19 and 8 have in common, the GCF, is 1. but you can write as a mixed number. Just make sure you write it correctly, though. All right, so that is how you would deal with the fractions. Now let's go ahead and check this. So let me just show you how to check this. So that was a lot of work because you have to remember some things about adding fractions. So let's check this. So we're checking 19/8 to see if it works. So 19/8 minus 5/8, and I want to see if that's going to equal 7/4, right? Well, the denominators are already the same here, so we just subtract their numerators. 19 minus 5 is 14, so I get 14/8. Reduced, they're both divisible by 2. 14 divided by 2 is 7, and 8 divided by 2 is 4, and that's what I get. Okay? All right. Okay, so just a reminder about how to deal with fractions. Now your calculator may, if you know how to use your calculator, you can always do this on your calculator. So let me just show you how to do it on mine. So I have 7/4 plus 5/8, right? So you're going to say 7 divided by 4 plus 5 divided by 8, and you're going to press equal. So notice we have this decimal. But I want to convert this decimal to this improper fraction that we saw here. So to do that, on my case, I've got to see where it says, you can't see very well, but right above PRB, you see F to decimal, decimal to F means fraction, decimal to fraction. It's a different color, so I got to go to second. So I'm going to press second, and then this PRB button. So you see it gets this now, and then press equal. So now it wrote it as a mixed number, 2 3/8. Does that look familiar? 2 3/8? It should. That's just right here. So that's how you would use it in your calculator. You can easily do this in your calculator to get it to a mixed number or a fraction if it's not a mixed number. And if you want to change it back to a improper fraction, then you would take that 2 3/8 and you would say 8 times 2 is 16, 16 plus 3 is 19, so you get 19/8. Okay? All right, so let's look at number 8. So number 8, we have this for number 8. We have C plus 2/7 equals 5/14. C plus 2/7 equals 5/14. So right now I'm adding 2/7 to C. I want to get C by itself, so I'm going to subtract 2/7 from both sides, just like this. Now combining like terms, make sure you say subtract, okay? That's important. You got to show that operation. So 2/7 subtract 2/7, that's 0. So C plus 0 is C. And let's go off to the side and figure out what this is. Now on a calculator, you can do this quickly, but you do need to remember how to manually, without a calculator, to do this by hand, okay? But let me just kind of show you how to, on mine, how to do it again. So we have 5/14, subtract 2/7. 5 divided by 14, subtract 2 divided by 7. Press equal, and I get this decimal. It doesn't terminate, does not terminate, so I'm going to change it. So I want to change this, since this is written as a fraction, I want to write my answer as a fraction. So second PRB, press equal, and I get 1/14. All right, so it's not a mixed number, it's a proper fraction. So the answer is 1/14. All right. Okay, but let me just do it by hand just to remind you. So we have 5/14 subtract 2/7. So we got to find the least common denominator. What's the least common denominator? The least common denominator is 14, right? So LCD is 14. So I'm going to write two equivalent fractions with 14 as the denominator. Well, so 5/14 is equivalent to what fraction? Well, 5/14. So these denominators are the same, so the numerators must be the same. Now over here, those denominators are not the same, so I got to think. What do I need to multiply 7 by to get 14? Well, I got to multiply by 2, but what I do to that denominator, I must do to the numerator. So 2/7 is equivalent to what fraction? 2 times 2 is 4, so 4/14. And it'll make sense because if you reduce 4/14, you get 2/7 back. And now you can subtract those two fractions because they have the same denominator. So 5 minus 4 is 1. So you get 1 1/14th, let me write this over, 1/14th, which is what you saw there. Okay? All right. Now let's look at number 9. Number 9, we have 2/3 equals x plus 1/4. 2/3 equals x plus 1/4. So to get x by itself, right now I'm adding 1/4. So the opposite of adding 1/4 is to subtract 1/4 from both sides, just like this. What you do to the right side, you do to the left side. You got to show it. Then combining like terms, 1/4 minus 1/4 is 0. So you get x to be 2/3 minus 1/4. So let's go off to the side and do this by hand. 2/3 minus 1/4. The least common denominator of 3 and 4, the smallest number that 3 and 4 go into evenly is 12, right? LCD here is 12. So I'm going to write two fractions with 12 as the denominator. So I want to go from 3 to 12. So 2/3 is equivalent to what fraction? So I need to multiply 3 by what to get 12? Well, 3 times 4, but what I do to the denominator, I must do to the numerator. So 2 times 4 is 8. So 2/3 is equivalent to 8/12. Now we do the same thing with 1/4. So 4 times 3 is 12. 1 times 3 is 3. So 1/4 is equivalent to 3/12. Now the denominators are the same, so I just subtract their numerators. 8 subtract 3 is 5, so I get 5/12. And that's it. All right, that's your solution. All right, so the solution for number 8 was 1/14. And so that is our lesson on using the addition and subtraction properties of equality.